Now, trigonometry problems always cause more difficulty, so let's take a look at a couple of these ones. Before we do that, we always want to think of something slightly more simple. So if I was to start off with, say, the tan of x, and I see to differentiate it, differential of tan is just going to be secant squared. So secant squared of the same thing. Now, if I was to make this tan 2x, then it's going to be secant squared 2x, but we also have to times by the derivative of 2x, which is 2. So the important aspect about when you differentiate tan, you're going to differentiate what tan is of, bring that to the front, and then put secant squared of whatever we had to begin with. Now that's going to be important when we start doing more complicated questions. So for the tan of xy, we know the differential of tan is secant squared of the same thing. We also have to times by the derivative of xy. So that's going to be our product rule. So we're going to do the first term times by the derivative of the second. And if you're not comfortable doing this, then you could just do the u and v rather than trying to substitute it directly. Plus the second term times the derivative of the first, which is just 1. So our answer would be x dy by dx plus y times by secant squared of xy. Now, if we move on to question 2, then we should recognise this as a chain rule question. So this power of 3 here, it'll let me get rid of it. No. So we can write it all to the power of 3. So when we differentiate this, we bring the power to the front, leave this alone, decrease the power of y1, and then we have to times by the derivative of what's inside the parentheses. And actually what's inside the parentheses, this tan xy, is actually what we have in the original question. So the derivative of tan xy is all this stuff here. So I can just tag this on the end here. And you can see that we actually start to get some very long answers here. But when you're trying to do these questions, think of a simpler example first, and then try and relate that into the question that you're actually answering. And hopefully that will help you to come up with a good answer for these.